Hello everybody, today we're doing LEET code 11, container with most water. You're given an integer array called height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height sub I. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Example 1. Your height array is 186254837 and the output is 49 because out of all of these possible heights, the largest amount of water that you can store is right here, and the area for this is 49 because this is 7 and this is 8, and the distance between 8 and 7 is 1, 2, 3, 4, 5, 6, 7 times the height. The smallest height between 8 and 7 is 7. 7 times 7 is 49, and that is the area that we end up returning. One way to go about this is by having a nested for loop where you have I and j, and you loop through the indices and find every single possible combination of height that there could be, and you keep track of it with a temporary area, and at the same time you update your maximum possible area with every iteration. So for example, when I is at index 0 and the value is 1 and j is at index 1 and the value is 8, we can do area equals length times height, and the length for this would be j minus I times the minimum height between these two values. Is it 1 or 8? And in this case it's 1. So j minus I is 1 minus 0 times 1, which is equal to 1 because the area that we're looking for is right here. Our temporary area is 1 and we're looking at max, which is 0. Which one is greater? It's going to be 1, so we'll update max to 1. After that, we'll move our j pointer up by 1, calculate the area for this. And we go through it and we continue to update max. And then at the very end, we'll return the maximum value that we've come across during all of the iterations. The time and space complexity for this approach is O of n squared because of the nested for loops, and we're checking every single possible iteration, or we're checking every possible combination of I and j. And for space, we're not taking up any extra space, so it'll be constant O of 1. For this approach, n squared, it's definitely the naive approach, and you'll absolutely get the answer that you're looking for. But if there's a time constraint, or if you want to run it a little faster, we can talk about another way of going about it. So another way of going about it is by using the two-pointer technique. And the two-pointer is using a left pointer at the very left and a right pointer at the very right. And the condition that we stop is when left is less than right. And it's the same idea. We'll have a max area variable set to 0 in the very beginning, and we're going to check our area between left and right. And for every combination that we have that we come across, we'll update max as we go along. This is a little bit faster than the n squared approach because we have just one pass going through this array. We have our area equals length times height, and we know that to find the length, we want to do the index. So that is the index for right and minus left times the smallest height that we come across. So the values 1 and 7. So the smallest height between these two values, 1 and 7, will be 1. Right is currently at the 8th index, so 8 minus 0 times 1 equals 8. Our area at this moment in time is 8, and our maximum is 0. So we want to update our max to 8. So after we've updated our max to 8, we're going to arbitrarily just move the left or the right pointer. In this case, I like the idea of moving the left pointer first because in this very specific problem, left happens to be the smaller value. So we're going to arbitrarily move left up because it has the smaller value. So now that left is at index 1 and the value is 8, we're going to find our new temporary area and update max as we go along. So for length is the index for right minus left times the smallest height value, which is 8 or 7. So that will look like 8 minus 1 times the smallest height value is between 7 and 8, and that is 7. So 7 times 7 is equal to 49. We compare our area 49 49 and our max, and 49 is greater. So we'll update our max to 49. And now we have our left pointer and our right pointer, and comparing the two values, 8 and 7, 7 is the smaller value, and we're going to just arbitrarily choose to move right down by 1 because that's just what makes sense. You can alternatively do it the other way where you just move the right pointer, but we're sticking to this and this is what we're going. So we move right down and then we find this area for the right value and the left value. So this is the area that we're looking at. So right, which is at 7 minus 1 times the smallest height is at 3 or 8. That's going to be 3. 7 minus 1 is 6 times 3. 6 times 3 equals 18. Our area is 18. Is 18 greater than 49? It's not. So we'll keep our max as 49 and we'll keep iterating through using our left and right pointers until we meet at the middle when left is less than right. And that's when we finish our loop. And at the very end, we'll return whatever is the greatest maximum that we've come across. And for this example, it's going to be 49. So let's go ahead and talk about the time and space complexity for this problem. The time, because we're not using a nested for loop and we're just using 2 pointers with 1 pass, it'll be O of n time. And for space, we're not taking up any space. We're not building any storage. It will be constant space. Now let's go ahead and see what this would look like in the code. So we're going to start off by creating our temporary max variable. Let max, let's be explicit about this, let max equal 0. We want some other variables going on. We want our left pointer, our right pointer equals height minus 1. And what else do we want? We also want a temporary area. So to loop through this, we're going to have the condition while left is less than right. And during every iteration, we want to update our temporary area and figure out what that is and then update our max area. The temp area, so we know that area equals length times height, and we want to do temp area equals the length, which is our indices, so right minus left, times the minimum height values of right or left. So we'll do a math.min of height sub left or height sub right. Once we get the area, we'll update our max area. Max area equals math.max temp area or max area. Just going to clean this up, and after we figured out our max area, we want to move the pointers. So we're going to see if the value for our left pointer, if that value is less than or equal to the value for the right pointer, we're going to increase the left side, else decrement the right side. If height sub left is less than or equal to height sub right, will increase the left side, else decrease the right side. At the very end, we return our max. Let's go ahead and run through some sample test cases. Looks good. And there you have it. That's a way to go about it. If you liked this video and would like to see more, please help out by liking and subscribing. See y'all soon.